Hi, I'm Moy from DEEE 2B27, and today I'm going to explain the characteristics between the difference in the rules and use of two rules, compare and contrast the advantages and disadvantages of the two rules, which I will summarize in the table, and I will explain to you are there any methods for computing integration numerically. Okay, now I'm going to explain the advantages and disadvantages between Simpson's rule and trapezoidal rule. For Simpson's rule, the advantages is that error reduced proportionally to the square of the data spacing. And for advantages of trapezoidal rule is that it can only use for odd and even number can be used only. Then now to disadvantages of Simpson's rule, there must be an odd number of data points. The data must be evenly spaced. It can only work if the number of streets is even. For the disadvantages of trapezoidal rule, it can only use trapezium formula to calculate the area. So now, for characteristics of Simpson's rule, it can divide the area into an even number of strips, each of which h equals to b minus a over n. Number and evaluate each ordinate. Example y0, y1, y2, yn. Okay, for characteristics of trapezoidal rule is that divide the area into strips of equal width, approximately each strip to be trapezium. Area of trapezium equals to half bracket a plus b h. The method for approximating a definite integral sign ba fx dx using linear approximation of trapezoidals. Okay, for differences of Simpson's rule is that for this one, integral sign ba fx dx equals to h over 3 bracket y0 plus yn plus 4y1 plus y3 plus yn minus 1, then equals to 2 bracket y2 plus y4 plus yn minus 2. When for the difference between trapezoidal rule is that integral sign ba fx dx equals to half bracket y0 plus y1h plus half bracket y1 plus y2h plus half bracket y2 plus y3h equals to h over 2 bracket y0 plus 2y1 plus 2y2 plus 2yn minus 1 plus yn. So the formula for trapezoidal rule is integral sign ba fx dx equals to h over 2 bracket y0 plus yn plus 2y1 plus y2 plus yn minus 1. So now I will proceed to other methods for computing numerical. Okay, now I will explain to you there are still other methods of computing numerical integration. One of the methods are manual method. This method is to perform integration by hand. One approach is to superimpose the grid on the graph of the function to be integrated and simply count the squares, counting only those covered by 50% or more of the function, provided the grid is sufficiently fine. A reasonable, accurate estimate may be obtained. This example of the graph, you have to count the squares, and the squares which shaded is counted. So another method for computing numerical integration is quadratic triangulation. Simpson's rule may be employed in a manual way to determine the integral with nothing more than a ruler. The approach is to cover the domain to be integrated with a triangle or trapezium, whichever is geometrically more accurate, is shown in figure 17, which I will show you later. The integral may cross the side of the trapezium connecting the endpoints. For each arc-like region so created, there are two in figure 17. The maximum deviation indicated by arrows in figure 17 from the line should be measured, as should the line of the chord joining points of crossing.
From Simpson's rule, we may approximate the area between each of these arcs, and the chord has area equals to 2/3 chord maximum deviation. Remember that some increase the area while other decrease it relative to the initial trapezoidal estimate. The overall estimate ignoring linear measurement errors will be 0 bracket length 5 where L is the length of chord. So, and this is the figure 17 which shows the graph, and this is the arrows